Welcome! Okay, so today we're going to do applications of exponential functions. Now, these are really cool because I know you guys, I know you love formulas, okay? When all you have to do is just plug in certain things. And that's all we're doing today, okay? We have a formula and we're just plugging numbers in based on what the word problem says. So, when we talk about exponential growth, there is a formula for that, okay? And it occurs when a quantity exponentially increases over time. And the formula is y equals a 1 plus r raised to the t power. Now a is going to be your initial amount. Your r is going to be your growth rate. And it's usually going to be in a percent or decimal. And your t stands for time. Okay. So let's read number 1. The original value of an investment is $1,400, and the value increases by 9% each year. Use an exponential growth function to find the value of the investment after 25 years. Now sometimes they're not going to tell you to use an exponential growth function, okay? You're just going to have to be able to see, okay, if we're talking about exponential or not. So you just have to read for context clues. So, but as soon as I know it's going to be exponential, okay, I'm going to list these three things. A equals R equals T equals, okay? And I'm going to go ahead and write out my formula. Okay, you are going to have to memorize this. Okay, so A again is my initial. So what do I start out with? Okay, it says the original value is 1,400. So that's going to be my A. My rate, okay, and the reason why we know this is growth is because it says increasing by 9%. It's 9%. But in this formula, it only likes decimals. So we have to change this to a decimal, and the way we change a percent to a decimal is we move it, the decimal point, 2 places to the left. So I have 1, 2. So it's going to be 0.09. Okay, and in my time, it tells us 25 years. So now we're just going to plug that into the formula. So plug 1,400 in for A. 1 plus my rate is 0.09. T is 25. Okay. You're going to put all that into the calculator and you get y equals $12,072.31. Now I'm going to go get my calculator so I can show you how to plug that into your calculator. Alright, so to plug that in, I'm going to do 1,400, okay, parentheses, 1 plus 0.09, close my parentheses. Then I'm going to come here, the little caret symbol. Okay, and I'm going to put my exponent, which is 25. Enter, and it gives me my answer. Okay, so again, close parentheses. To do your exponent, you press this little button right here, and that will save you time. Okay, let's do this next one. The cost of tuition out of college is $12,000 and is increasing, so we know we're going to use the growth formula. At a rate of 6% each year, using the exponential function to find the tuition cost after 4 years. Okay? Again, sometimes it's not going to tell you to use the exponential function. You're just going to have to know to use it. And a way that's a good hint is increasing at a rate. Anytime you're increasing at a rate, okay, it pretty much means it's going to be exponential. Okay, so I'm going to write out my formula. It's growth because I am increasing. So 1 plus R of T. I'm going to write out my values. Okay, so A is my initial amount. So So what do I start off with? And I start off with 12,000. Okay, my rate is 6%. So to change that to a decimal, move it 2 times to the left. So I have 0.06. It will be wrong if you do not change it to a decimal. And then my time is after 4 years. Plug these into the formula. Okay. And now we're going to use the calculator to do it. We'll have 1200 parentheses 1 plus 0.06, close it. To do the exponent, press the caret to the 4th power, and I get 1,000. I'll get $15,149. Okay, and I forgot a 0 up there. There we go. 15,149. $0.72. Okay. So I want you to do 3 and 4 on your own, then come back and we will go over the answers. Okay, welcome back. So a number of student athletes at a local high school is 300 and is increasing, so we're going to use my growth formula, at a rate of 8% per year, using an exponential function to find the number of student athletes after 5 years. Okay, so I have A or T. My initial amount is 300. My rate is 8%. Change it to a decimal. I have 0.08. And my time is 5 years. Okay, we know it's growth because I'm increasing. And plug in my values. Okay. So when I put that in the calculator, I'm going to get 440 student athletes. Let's look at 4. Annual sales for a company are 149,999 and are increasing at a rate of 6% per year. Uses exponential function to find the annual sales after 7 years. Okay, so again I have A or T. Okay, my initial is going to be 149.99. My rate is going to be 6%. Change it to a decimal, move it 2 times. I have 0.06. And then my time is 7 years. Okay, we're going to use my growth because we know it's increasing. Okay, plug in my values. Okay, put that all in a calculator and you should get this. Okay, and that is my answer. Okay. So this is growth, okay? For decay, okay, it is very cool for exponential decay because all you do to the formula is you make this plus minus. Now we're going to look at decays. Okay, again, same thing as the exponential growth, except you're going to have a minus sign. So it's A1 minus RT. Okay, A is still your initial amount. R is your decay rate, so you're going to be decreasing. And then R is time. So let's read. The population of a town is decreasing at a rate. So decreasing is going to mean we're going to use my exponential decay. So I'm going to do 1 minus R. Okay, so I'm going to have A, I'm going to have R, and I'm going to have T. Okay, it's decreasing at a rate of 1% per year. In 2000, there were 1,300 people. Using the exponential function to find the population in 2008. Okay, so my initial amount, okay, is going to be 1,300. That's what I'll start off with. Okay, my rate is going to be 1%. Change it to a decimal. I'm going to have 0.1. Now my time, pay really close attention. Okay, when they give you years, okay, years is not a number. Okay, you need a actual number. It's just like when we did scatter plots. Okay, so they want to know, find the population in 2008. So if we start in 2000, how many years has it been since 2008? So my T is actually going to be 8. Okay, so when you talk about years, you need to do the amount of years from the original year. Okay, so from 2008, 2000 to 2008, it's 8. 8 years has gone by. You're going to put like 8 in, not the year 2008, because it would give you a crazy answer. Okay, you're going to plug these values in. And you get y equals 1,200 people. Okay, and this is my answer. Okay, let's go to number 8. The value of a car is 18,000 and is depreciating out of weight. So this means going down. So anytime you see this, okay, it's going to be decreasing. You're going to use your decay, your exponential decay. 12% per year. Using an exponential function to find the value of a car after 10 years. Okay. So again, that means I'm going to use my decay. Okay, I'm going to come over here and write everything. A equals R equals T equals. So my initial amount is going to be 1,800. My rate, okay, again, I'm going to move it 2 places to the left, so I have 0.12. And my time is going to be 10. Plug these values in. Okay, put it in the calculator and I should get $5,013.02. Okay. So again, pay really close attention to these problems. Up here, okay, anytime you have a year, okay, and guys, I'm telling you this because I saw a lot of mistakes on that last test that you took. Okay, you have to convert years to the number of years since then. Okay, you can't just put 2008 in here. Okay, you have to do the amount of years from that original year. Okay, so I want you to try 9 and 10 on your own, and then come back here to check your answers. Okay, welcome back. So a farmer buys a tractor for $50,000. If the tractor depreciates, so I'm going to use my decay formula. At 10% per year, use an exponential function to find the value of a tractor in 7 years. So my initial amount is going to be 50,000. My decay rate is going to be, move it 2 times, 0.10. And then my time is going to be 7 years. Plug that in. I have y to equal 23,914.85. Okay, and that is my answer. Number 10. An investment of $8,200 loses value at a rate of 2% per year. So it loses, so I'm going to do my decay. Use an exponential function to find the value of an investment after 9 years. So my initial amount is going to be 8,200. My rate is going to be 2%. Change it to a decimal, so I have 0.02. And then my time is going to be 9. Plug all that in. and I'm going to get y to equal $6,836.73. Okay. So for your homework, okay, you're going to have these problems all mixed up, and you have to be able to say, okay, I'm going to use the decay one, or I'm going to use the growth one. The only thing that is different between the two is minus or plus. Okay. So if it's saying your increase in rate, you're going to use plus. If it says decrease in or depreciation, you're going to use your negative. Okay, you can use minus. So these are just reading through it, just plugging numbers in, and that's pretty much all of today's lesson. If you have questions, please let me know. Hope y'all have a good day.